Alright, you guys. First of all, I want to apologize for the delay. This has been a pretty big project trying to get all of my notes together and my knowledge over the years. I do apologize if you're a fan. It was a little hot out, so I have a fan on. Alright, so we're going to start out by talking about the summer workshop. The main goal of the summer workshop is to get everyone on the same page, make sure everyone is familiar with the same exact parts. What I mean when I talk about different parts, when I talk about programming later on, you guys will understand what I'm referring to, what part is talking to what. I'm just kind of give you guys the ground layer of First Robotics, give you guys a good idea of what to expect when you're on an FRC team. So this week we're going to talk about the general robotics parts, and I'm going to kind of give you guys a brief explanation of how those parts work, at least most of the parts. I'm not going to talk about pneumatics too much. I defer to other people's judgment on that one, and I'm not going to get into wiring too much today, only because that's a week all its own, the technicality and understanding DC voltage and circuitry, so we'll get to that at another time. Alright, so what we'll talk about today is we're going to talk about the frame, kind of go over how the frame is assembled, what goes into the frame, why it's important. Then we're going to talk about our drivetrain and the subsystems. As far as subsystems go, I'm going to talk about ones that we've made in the past. I don't want to get too crazy because a subsystem could be anything from an arm to a ball shooter to a frisbee thrower to a suction cup with a boot attached. It could be pretty much anything that isn't a main system like the drive system. And we'll talk about what that means, what the heck a subsystem is versus a main system, all that. Third, we're going to talk about the electronics, talk about what parts make up a basic kit robot. Nothing crazy. We're not going to go and list through all the sensors. There's not enough time for that. After that, we'll talk about the drive station and the controls, so you guys understand when we say, oh, well, where's the drive station? Well, this is what we mean by the drive station. And then I'm just going to recap everything I've talked about, just make sure you guys understand. What's nice is you're going to have a video now with the slides that I'm talking about, so you guys will actually be able to go back and re-watch something if I talked a little bit too fast. Alright, so let's talk about the frame. The frame has some main parts. We have our sides, our underbody, there's churros. They're not really a main part, but they're an important part, so I feel like I need to talk about those. We have our bumpers, we have other mechanisms that actually mount onto the frame, and we have the electronics board. So first we're going to talk about the sides of the frame. If you've been to a competition before, you're going to know what I'm talking about. If not, the picture on the slide demonstrates a basic kit bot pretty well. A kit bot is either a square or rectangular bot made out of the kickoff kit that you receive from First Robotics. If you're a rookie team or even a returning veteran team, you're going to get this box unless you opt out. I haven't found a good reason to opt out yet. Worst case scenario, this gives you some robot that will actually function, and if you expand on it, great. If not, you're still going to learn a lot about robotics by building this bot. You can either have 4 or 8 sides. Your kit bot, that's going to actually be 4-sided, so either a square or a rectangle. But we've also seen robots that are 8-sided, meaning they have kind of an octagon shape. The octagon isn't common. It's not something we've done in the past, but a lot of teams, when they do omnidirectional wheels or omnidirectional shooters, meaning all directions, it gives them a little bit of an easier way to move around in kind of a circular fashion. Biggest problem when you get kind of an octagon-sided base or even a square base, it's not as common, but octagon base, it doesn't give you a whole lot of room to work with. FRC has a frame perimeter of 120 inches, meaning you measure all the sides without the bumpers, and if it comes out to more than 120 inches, it's too big. So if you have 8 sides, you've got to take 120 and divide that by 8. And the more sides you have, the less big those sides can be. It's just basic math. Last year, our robot was 30 inches by 30 inches, so it was perfect square. And that seemed to work out really well for us, but in years past, we've done usually 20 by 40 by 20 by 40. Meaning, short sides 20, long sides 40. So the octagon, the reason you're going to have a problem, you don't have as much room to work with on the inside. You have a smaller area, even though they all have the same perimeter. Which means you actually have to make the robot taller to fit more in, and as you get taller with your robot, it's likely to tip over. So with your basic kit bot, and that's what I'll talk about for the most part today, you're going to have two side panels on each side. And if you look at the picture, that's actually what I have the arrow pointing to on the robot, saying, first of all, this is the side, but there's actually two side panels for your left and right sides. Your front and your back panel, that's actually just one piece on each of those sides, meaning most of your stability is coming from your sides. The sad thing is, on the sides is where your wheels and your motors, that's where all that's going, so you need a lot of support. And that leads me into the underbody. So the underbody, and I have a picture of our robot from last season, is a plate that goes underneath your robot that holds everything together. Some teams choose to go without them. In 2015, so that was the year of Recycle Rush, we didn't use one. We actually had just a metal track on top of our robot that held the electronics and kind of pulled the front and back panels together, and we just used some metal beams or struts, metal bars almost, that went across from side to side, almost like a really long churro, that actually held that together. If you want to go that route, that's fine. Last year, so that would have been the year of FRC Stronghold, is a pretty rough year. You're going over metal or plastic or even wooden obstacles if you're practicing. At competition, you've got metal and plastic obstacles that you're running over with your robot. And you want your robot to be sturdy, and you don't want it to just break apart on you. So you need something underneath there to protect yourself. Your electronics actually sit on top of this for the most part, or on their own separate electronics board, and I'll talk about that. But you need something sturdy. Last year we used steel because we knew this was going to be a rough year. Steel is heavy, but it's super duper strong, and that worked out for us. Most teams will use plexiglass or aluminum, just because those are lighter weight. Aluminum, it's strong, but it's kind of pliable, so you have to be careful. If you're having a really rough game that year, and you're driving over obstacles and you start getting bumps in the bottom of that frame, if it gets too much damage, you either have to replace it, or you got to sit there and hammer out all these creases all the time, and then you're going around wires with a hammer, and it's a big mess. Plexiglass, most years, is okay, because most years aren't as rough as FRC Stronghold. Alright, let's talk about churros. So churros sit in between the sides of your frame. And the reason they're called churros is if you've ever seen a churro before, they literally look like a churro. You get a whole bunch of these that come in your kickoff kit, but they're not custom cut, meaning you have to make sure you're getting your measurements and then cutting these. You can do these on the bandsaw. They don't get too hot if you do it right. Make sure you spray water. Our team, we've actually used a reciprocating sawzall in the past. That worked out well when we were at competition because you can't really take a bandsaw with you to competition. But the churro, sometimes they're threaded, sometimes they're not. You want to make sure you thread them if they don't come threaded. Those attach in between your outside and inside walls on the left and right side. There are no churros that go in the front and back. If you take the churro bar straight out of the kickoff box, though, if you make the width robot they suggest in kit, which you don't have to, and I don't suggest doing because you want to customize it to the year, but you can actually stretch that churro across from where your gearbox mounts on those inner panels, and it'll actually stretch all the way across to add some extra support. Especially do this if you don't have an underbody. So the churros, the way they attach, imagine if you had your sides of your robot like a sandwich. Your outside wall is one layer of bread and your inside wall is the other layer of bread. Inside there, you've got belts, hubs, all this stuff sitting inside there, and it's just going to squish together. The churro sits inside of there like a toothpick, kind of holding everything together so it doesn't slip and slide apart. And yeah, you have bolts attaching it on the perimeter, but you want to be secure. These robots go through hell and back every year, so you want to give them the best advantage they can have. So these sit in between, and there's actually pre-drilled holes on most of the kit bots I've ever worked with. There's pre-drilled holes for where you can put your churros, and they have special bolts that should come in the same bag that will actually thread the churro for you as you tighten them in with a wrench. But make sure that you do this, you get them tight. You don't want to drill custom churro holes until you are sure what wheels you're using. The reason I say this, we ran into an issue last year where we decided we wanted to go with 10-inch wheels, which we didn't get any from AndyMark. It was a whole big mess. So we made the robot for 10-inch wheels. Well, then we decided, okay, we're using 6-inch wheels. And so now our churro holes were right in the way of where our new belts were going. It was a big mess. So make sure you have all your plans down first before you start drilling holes into those panels, even for Churros. You just want to make sure you're extra ready for what's going to happen, because you don't want to have to destroy an entire frame and then order a new one, because they're not cheap. Alright, bumpers. Bumpers vary year to year, and they're going to change depending on what your robot looks like every year. There is no set, this is FRC's official bumper design, this is what you have to have. Every team has something different. Personally, we've always used rectangle bumpers. We've tried doing full robot bumper, meaning you have like 2 panels and they cover the entirety of the robot. Lately though, we've gone with the corner bumpers. They're a little bit easier to make. You can conserve pool noodles if something happens. It's less repair work. And last year we actually went with what we called reversible bumpers. And the reversible bumpers give you an advantage when you're trying to save time making the bumpers, and it saves you time at competition. Reason I say this, if you've been at FRC, you know what I'm talking about. You have to change bumpers constantly. We never had it as bad as last year. Last year it was every single match, it was red, blue, red, blue, red, blue. Like no joke, I'm sure I can find the schedule somewhere. It was every match we were changing colors. That's not common. Sometimes you'll get breaks where you're 2 matches through a day and you're the same color, or 2 matches in a row, 3 matches, whatever. But you want to make it so you can change out your bumpers quickly and easily. Your bumpers, if you don't know what they are pool noodles. There's 2 of them, one stacked on top of the other, attached to strong wood. I don't recommend using basic plywood. If it's a full contact year, you're going to run into issues, and that board, even particle board, that stuff's going to break up. You want to make sure you're using something strong that's going to hold up, clashing against metal and other metal. Sometimes going at speeds, I've seen robots go up to 50 miles an hour in a speed test. Obviously, not enough room on the field to accelerate that fast. But looking, in the 20 mile an hour range coming at your robot, it's going to take a lot of impact. And a pool noodle can't stop all of that, but it helps. So these pool noodles, they get wrapped in cloth, attached to a board, and then that board sits on all 4 corners of your robot. At least all 4 corners, if not the entire robot itself. The picture in the slide is actually a model I found just on Google, just looking for some type of an example of a quick release bumper system. This one here, it uses little pins that have rings at the top, and you can pull out the ring and then you can slide the bumper off and change your color. And I think in this picture, even though it doesn't show you how it does it with reversing bumpers, you can see how there's some red cloth tucked underneath the blue. And what we did last year was our red cloth was actually Velcroed on top of a pre-made blue bumper. So we could just put that on top as a cover when we were red, rip it off in not even 5 seconds when we were blue. And we could change it as we needed to do it. And that way we made 1 set of bumpers, so 8 corners, or 4 corners instead of 8. So it saves you time and material, and it's a pretty cheap and quick way to do it. Alright, next, let's talk about other mechanisms. Again, I used a picture of our robot from last year just to demonstrate how a mechanism would attach to our frame. It might be a little bit hard to see, but this is our shooter that was designed for FRC Stronghold, so to shoot the dodgeball, essentially. This actually mounted on top of our frame on the inside wall, and we had to kind of move it up a little bit, so we added some custom metal work. But the frame can actually support quite a lot of abuse, and it can hold your mechanisms pretty sturdily, or even if you attach them to the underbody of your frame, it can still hold those in place. My word of caution is, though, if you only rely on the frame and don't give it any other support, like Churros or anything, to hold these mechanisms in place, they are going to bend your frame out of shape. And we had an arm that we got rid of the shooter, and we created an arm that just sat on the front of the robot to trigger obstacles. And this arm was powerful enough to actually lift up the front end of the robot off the ground to get over the, I want to call it the rock wall. I don't think that's the right name from last year, but it was essentially one long 4-inch bar that sat in the middle of the field. That arm, throughout extended use of competition, actually started to bend our front panel of our frame up, and we would have to hammer it down when we would get back to the pit. What we should have done is actually put some Churros in there and just ran some bolts through just to hold it in place so it wasn't going to bend out of shape. I recommend doing that if you've got something that has a lot of torque to it. And I'll talk about torque versus force versus pulling power when I get to the electronics. As far as mechanisms go, they can be any shape, any size, any form. I take that back. Not any size. You're stuck with your robot size, but I've seen big things, little things. They're all over the place. Sky is the limit. With your mechanisms, you just need to figure out how they attach before you actually make the mechanism. It's all fine and dandy if you make the world's best shooter, but unless you have a way to fit it inside your frame or attach it to your robot, it doesn't do you any good because it won't actually be part of your robot. Alright, next we're going to talk about the electronics board. Your electronics board, as the picture shows on the right, that one is actually a plastic board. I recommend plastic or plexiglass, strong plexiglass I should add, as opposed to using wood or some other materials. The reason is your electronics are carrying, hence why they're called electronics, electricity. They have electricity inside of them, and you don't want those electronics in any situation to short out, because that can seriously hurt your robot, mess up your match, mess up your entire competition in some cases. Plexiglass and plastic and even wood, for the most part, is non-conductive. Non-conductive meaning it's not going to short out or short out your electronics by getting a current sent through it. It's not going to be the end of the world. If you put your electronics straight onto, let's say you have an aluminum underbody on your robot, and you put your electronics right on there, you run a risk of a wire coming loose and shorting out, and now you're done. Whereas if you had an electronics board, all your wires are held to that board. They're not going to go anywhere. They're not going to short out. They're not going to come loose. And you're going to have a nice, safe, secure robot. The best part, too, is you can do all your wiring ahead of time while build team is still finishing the frame and your mechanisms. You can wire all of your motor controllers and not motors, but your motor controllers, your Robo Rio, your PDP, your pneumatic control modules, all of that stuff on this board, and actually do bench testing this way. So I highly recommend making one of these every single year. Make it custom for what you're doing. If you're making a skinnier robot, make a skinnier electronics board. If you have a square robot, then go with a square board. You can cut the board to whatever shape you need. I've seen in some cases teams that actually have 2 or 3 separate boards, and they're just linked together through a small piece of plexi on the bottom, so you can grab it all as one piece. But then you can mount things sideways if you need to. There's actually some teams that'll 3D print custom electronics boards. If you have a 3D printer and you're proficient in CAD, be my guest, because that gives you a lightweight material that you can customize for different size electronics instead of a one-size-fits-all thing. That's totally up to you, but definitely make it non-conductive. That's the point I want to stress. Non-conductive is key. Alright, so let's talk about the frame. I'm going to recap what we've talked about, and here's kind of the main things you need to understand. Your sides, those are the main body of the frame. Without those sides, you've got nothing. That is the shape that holds your robot together. That's everything that holds the robot together. Your underbody sits underneath that frame, and it gives you stability, and it gives you somewhere to mount things to. So you can mount mechanisms, your electronics board goes there, your motors will actually occasionally sit on there, it depends what you're doing. But it's an important thing. If you choose to go without it, that's fine. Just keep in mind that you're going to have somewhere for your electronics to actually sit, because they can't hover in the air. We're not at that point in human history yet. So it's important to have somewhere to put all of this stuff that goes inside your robot. Your churros, those are for stability. Those attach in between the sides, not in the front and back, but in between the side panels. That's so important. Without those, your sides are just going to flex back and forth forever, and you're going to be so confused why our autonomous took you left and off the field and into the crowd. So it's important. Your bumpers, those are for safety, so they protect your robot, they protect other robots, and it also helps the refs to do scoring. So they're going to look and see, okay, that's a red bumper and that's a blue bumper. They're going to know what team you're on, and that's super important. Other mechanisms, like I said, you're going to learn that as time goes on, how to mount different things, whether you want to mount it across the whole board, whether you want to do it on the underbody, on the sides, on the front, on the back. That's up to you. Just make sure whatever you're doing is secure and it's not going to bend out of shape through abuse throughout the year. And last but not least, your electronics board. it holds all your wiring and electronics together. So you want to make sure that everything is securely attached to there. I've seen Velcro, that's what we use, that works pretty well. A lot of teams will use zip ties. Some of your motor controllers, you actually have screw holes. You can do those, just make sure not to tighten them too much because it'll break the plastic and then you're going to have a motor controller flopping around inside the robot, which is definitely not a good thing. Even if you think it sounds like a good thing, it's not. Awesome. Alright, let's talk about drivetrain and subsystems. So your drivetrain is made up of motors, belts, chains, sprockets, gears, gearboxes. There's so many gearboxes, I actually have it on 2 slides here. Your wheels, and then we're going to talk about the different drive styles that exist. So all the top things, all the way up until we get to drive styles, are actually all unique parts of the drivetrain. And then drive styles is just, well, what shape and what way does your drivetrain work? Alright, so let's talk about motors. This is what makes everything on your robot move. Your servos, those are motors. Even though they're not called motors, they are motors. They just have a limited range of movement. But let's talk about motors just in general, and then we'll get into specifics. Your motors, all FRC motors are DC. The reason we're not using AC means if you know what AC circuitry is, it's the circuitry you have in your house. Well, if you live in the US. If you live over in Europe, I think there's places that run on DC. I'm not an electronics expert, so don't take my word for it. But your motors, they're DC powered so they can run on a battery. Reason we don't have AC is we don't want to have a cord plugged into a wall that we're driving over with wheels and getting chopped with arms and whatever else is going on the field. So it's battery powered, so we need DC motors. FRC uses a 12 volt DC battery, meaning you can't have a motor that calls for 24 volts DC current, or even just high amounts of amperage, because it can't handle that. There's no juice there for it to get. You only get one battery on the robot, so you're limited as far as what you can use. First actually publishes a list in the kickoff kit and in the rules of what motors you're allowed to use. There's actually limits. So your sim motor, and if you look at the picture, that is the one in the top left corner of that picture. That's the black generic motor you're going to see everywhere. Your sim, you can only use 6 of those motors on your robot. There are companies that make mini sims. You're allowed to use as many of those as you want. There's companies that make things that are like sims. There's all sorts of stuff, and those are all acceptable in the rules. Animark, Vex, those are my 2 big places I look for motors, just because that's who FRC works with. We know those parts work, and they're good quality companies that are going to work with you. If you live in Michigan, I recommend buying your electronics from Cross the Road Electronics. They're very good at what they do. That's actually a Thunder Chicken's sponsor company. Why did the chicken cross the road? To get the other side, you get the idea. They're all part of it, so they understand what you're going through. But with your motors, your sim, you get 6 of those. Mini sims, 2 of those. You can actually gear up mini sims to achieve the same power you get from your sims. And why would you want to do that? Well, we need to talk about torque and force and pound limits. So your torque is how much power your motor has. The higher the torque, the more you're going to be able to move. So if I'm building something to pick up weights, I don't want to use a mini sim to try and pick up a lot of weight, because it's just going to burn out the motor and it's going to stall because it can't handle the job. I want to use something stronger like a regular sim. Your mini sim has 2/3 the power of a sim. It's a lot smaller, so it's actually a pretty nice trade-off. If you're constricted size-wise, I recommend going with the mini sim if you don't need a whole lot of pushing power or pulling power. But if you need a lot of power, like on your drivetrain, use a regular sim, because you can't beat it. It's the best that there is. And pound limits. So your motor can only do so much. It's only got so much power, so it can only lift so much. If you look online, or if you look for the manufacturer of that motor, you'll actually be able to find all the specs for that motor, so you'll know how much force that motor can pull or push. You'll know the pound limit of what it can handle. Your gearboxes, those will also have those limits, but we're not talking about gearboxes yet, so I'm not going to try and confuse you. Motors. So all motors, they move in a circle. They move what we call cyclically. If you think of like a clock, it starts out at 12, spins around, goes back to 12. Your motor can go clockwise, or it can go the reverse and go counterclockwise. So it actually goes in reverse. It only ever spins in a circle. You're not going to get a motor that moves in and out without some special gearing or different type of actuators. It gets really technical. The main thing you need to focus on is all your motors you're going to find for FRC spin in a circle. So if you have something you want to move up and down, you have to think about gearing and pulley systems, and we'll get to all that. Not too in-depth because this is just the basics, so you'll understand the terms that are being talked about. Alright. Next, we're going to talk about belts. So, belts, and not like the belt that you wear on your pants, but like belts that you'll actually see if you look inside an electronic scooter, like a Razor scooter. Mine had them. Some lawn mowers will actually use rubber belts. Some use chains, depends on who's doing it. Your car has rubber belts inside it. These belts are essentially rubber circles, and I don't want you to confuse them with chains. They do the same job as chains, but the way they're actually made and how they look are different. So your belt is actually rubber, and it has these little teeth that kind of look like ridges that interlock with what we call a hub. And I don't want you to confuse a hub with a sprocket, only because you're going to ask someone for a hub and then you really meant a sprocket, or vice versa. So you want to get the terminology correct. So a hub. They lock into a hub, and the hub has matching grooves that fit those little ridges that are on top of the belt, on the inside of the belt. A motor can actually spin the belt, but not just on its own. Without that hub, your belt's not going to spin. Your motor's going to try and grip into the belt, and it's not going to go anywhere. So you need a hub, and your actual kit bot, so the one that you get from First Robotics that you assemble, comes with belts and hubs that are all various sizes. So you need to figure out what belt size you need to fit inside your frame for what you want to accomplish. If you use the wrong size belt, you're probably gonna have a bad time, because your belt's gonna snap if it's too tight. If it's too loose, it's gonna fall off. So you need to find the right size, and you'll probably have to drill some custom holes in your frame if you're trying to do something fancy with your wheels. 9 times out of 10, you're not gonna have that problem. But like I said, last year we changed our belts so many times, and we changed our wheel size so many times. It changed constantly. So if you don't feel comfortable enough with chains, which I'll talk about next, if you don't feel comfortable, use belts. The reason you don't want to use belts in some cases, though, is you can't adjust the size. So your belt, because it's rubber, it's melted together, there is no end to the belt. It's just a complete circle. So you can't stretch them out or shrink them to fit a custom size. Whereas chains, which I'll talk about now, you can change them. You can take out an individual link or put more on to fit what you need it to do. So chains, they're made out of metal. Each chain actually has a gap inside it. So if you think of each chain link as a rectangle, the inside of that rectangle is hollow because a tooth needs to fit in there. So they work the same way as belts. So they spin around a hub sprocket, in this case a sprocket if you're working with your chain. They spin around there. Your motor on its own can't spin it without a sprocket. So it needs something to actually spin around. But it can take your motor's circular motion and actually turn it into vertical motion in some cases, or other things. You can actually use this, and this is how tanks work if you didn't know. Your treads on your tank are actually a type of a belt. That's the way they work. They spin around a roller or a sprocket, and those teeth lock in and give you traction to move around. I wouldn't recommend using FRC belts as treads, though, because they're going to rip up the carpet, and the FTA, so the field technical advisors, and the refs are not going to like you, and you don't want to get on their bad side. Alright, so chains. FRC likes to make things simple, and that's good, because this is simple, basic robotics for people who come in and just show up after school and say, hey, I heard you guys had a robotics team, I want to learn. So it's good that it's simple, and what's simple is it comes only in 2 sizes. Now, I don't mean you can only get a certain length, because the length, you can get any size length you want, so how many links you want. The width is what is only 2 sizes. There's either 25 or 35. And I'm not sure whether they're using millimeters or some made-up unit, but we just call them 25 chain or 35 chain. Your 35 chain is bigger and stronger, meaning it can hold more force because they're bigger. The bigger things are, the more they can usually hold. So your 25 chain, I wouldn't recommend using on your drivetrain. Your drivetrain is taking the bulk of the force your robot uses. It's what's pushing all of everything you have inside your robot along the ground. But if you have a shooter, like we had, you could use a chain to move that shooter up and down and change it along an axis. Alright, so sprockets. This is what goes inside of your chain. And the sprocket looks like a gear, if you know what a gear looks like, but it's not a gear. It looks like one, but it's not. This is what's inside. If you have a bicycle, this is what sticks inside the chain of your bike. It has little teeth that actually fit inside the hollow part of each link, and they lock in place. These teeth are also dependent not on length or diameter of your sprocket, but on the width, because you have either 25 or 35 sprockets. And it's important not to confuse the two. If you grab a 35 sprocket, it will not fit in 25 chain. But if you have a 25 sprocket and a 25 chain, it's going to work. You can get any size diameter sprocket you need. And we'll kind of talk about this when we get into gear ratios a little bit. But if you have a bigger sprocket on the actual motor itself, and you have a little one on a wheel, the big sprocket has to spin around more times to get the little one to go around once. So each time the little one spins, let's say it's a 10-tooth sprocket. I don't think that's a common size, but let's say for math, for simplicity, it's 10 teeth. Your bigger sprocket that's attached to your motor is, let's say, 40 teeth. So that little sprocket only spins around, that little sprocket spins around 4 times every time the big one goes around once. So that little one moves so much faster than the big one. And that's such an important concept, because if you're making a shooter and your wheels aren't going fast enough, instead of saying, well, I just need a bigger motor, you can actually reduce the size of motor you need by just adding better ratios and doing a little bit of math with belts or with gears or with chains, and actually accomplish higher speeds without more power being drawn away from your motor and from your battery and taking it away from other systems. Alright, gearboxes. Now, the picture I put on the slide, I just Googled for a gearbox. This one is so overly complicated. It actually uses 3 motors. That's crazy. I'm not going to talk about anything complex like that. And the thing with gearboxes is there's so many different designs. There's transmission gearboxes, there's shifting gearboxes, there's planetary gearboxes, there's ball shifter gearboxes. There's so many gearboxes, and every team could have a custom gearbox, and I'm not going to start just going through custom names for gearboxes. There's no reason for it. All you guys are here for is the basics of how these gearboxes work, and that's what I'll talk about. So gearboxes, they take the spinning motion from the motor, send that spinning motion through gears, and those gears change the amount of torque that's coming out of those motors. If you have a kit bot, you're actually going to get a gearbox and the kit, 2 of them, one for each side, the left and right. And that one actually takes 2 sim motors that go in. And there's gears inside there, and it actually gives you instructions in the box. Make sure you follow those, because I don't remember all the stuff. But it spins those gears, and those gears spin, and they meet up in the middle, and then it spins to a drive shaft that comes out of that gearbox that actually fits into the hubs. So you get a lot more torque out of that gearbox than if you just had one motor by itself spinning your wheels. So there's some math involved, though. It's the same math that I used with our chain example. So if you have an 8-tooth gear versus a 40-tooth gear, your 8-tooth gear spins 5 times faster than your 40-tooth gear. But this time we're going to do an example in reverse. So let's say you're a team and you're getting pushed around out there on the field, and you have belts or you have your gearbox, and you're getting pushed around all the time. Well, if you increase the gear ratio, so instead of going, 40-tooth gear spinning your 8-tooth gear, if you go 8-tooth gear spinning your 40-tooth gear, now you're not gaining speed, but you're gaining power, meaning the motor spins 5 times every time your 40-tooth gear would be spinning once. So you're getting 5 times more power, and there's kind of a trade-off. So you have to decide what's more important. Are you going speed? Are you going power? The faster you get, the less power you're actually going to have in that wheel. Whereas if you need more torque, then you need to go the other way. So you need littler stuff spinning bigger stuff. Alright, so this is Gearbox's Extended. And this is the second Gearbox I like because even though I talked all this stuff about gearboxes, there's 2 main styles you're going to run into with FRC. You're going to get your generic regular gearboxes that come inside your kickoff kit. And there's this thing called planetary gearboxes that a lot of teams will use and sometimes do actually also come in the kickoff kit. Your planetary gearbox, think of the planets, and this is why it has this name. Think of the planets orbiting around the sun. The sun is in the middle, and all your planets spin around it in these circles. Well, your planetary gearbox has a central gear, and all the other gears spin around that central gear. So you might have 5 of them, you might have 8 of them, you might have 20 of them, who knows? And again, there's so many variants of planetary gearboxes. You could have 1-to-1 ratio, all the way up to 100-to-1 ratio. And that's just from the basic sim adapting planetary gearbox that I found on Vex's website. I mean, there's so many choices, but the goal is, the thing you need to understand is it orbits around that center part. So if you have a confined space, but you still need gearing, I would recommend looking into a planetary gearbox. If you have all the room in the world like you do with your drivetrain on the sides, use the regular gearboxes that come with first. They're proven they work, and you've already got them, so why not use them? Alright, so let's talk about the wheels. And your wheel type changes year to year. It might even change in the middle of the season because you decided, I don't like these wheels, let's go back to something better. There are 4 main types of wheels you're going to run into with FRC. Pneumatic, meaning, air-filled tires, kind of like the ones you have on your car. But the wheels actually look a lot more similar to the ones you'll see on a dolly. If you know what a dolly is, I'm not talking about like a Raggedy Ann doll. I'm talking about like a metal cart that has air-filled wheels that people, like a FedEx driver, would use to move boxes. Those air-filled wheels are very similar to what you'll see for FRC. So that's pneumatic. We have plaction, and plaction isn't a real word, but in FRC it is. And plaction means plastic traction wheels. And if you look on the slide I included, there's actually a plaction wheel in the middle on top. And it's that white one. Those are the ones you get in your generic kickoff kit. And those are rubbery plastic type wheels. So they give you traction without going overboard. So first, let's compare pneumatic and the plaction wheels. The plaction wheels, you get traction just like you do with pneumatic, but the better part about pneumatic is if you're running over obstacles or you're bouncing, you're going to absorb a lot of that shock into that air that's inside those wheels. Whereas your plaction, you're likely to break your plaction wheels if you're hitting metal really, really hard right on the edge of the wheel. So you got to decide what's better for your game that year. Next is our rubber treads. I didn't include a picture of the rubber tread because I've seen teams use custom treads. There's also the Rhino treads that you can order from Andy Mark. If you want to use treads because you really like tanks, more power to you. The only advice I'm going to give you is be careful. If your treads are going straight front and back and they're attached on your sides, and you get pushed from the side, meaning someone T-bones you on the left, and they keep pushing, that tread has nowhere to go except stick to the ground and slide off of your rollers, and it's going to break, and you won't be able to move. There's teams that have actually solved this problem in the past. They've added, metal guards, or they've actually used a lot of tightening rollers to hold it in place. But I don't trust the treads. I haven't found a team that has given me a foolproof tread design, so I stay away from them for the most part. If you're not having contact with other teams, so like a year like Recycle Rush where you're not contacting people, more power to using treads because they're simple, they're easy, and they're not going to fall apart. You're always in contact with the ground at some point or another. The final thing is Omni wheels. And Omni wheels, and I kind of talked about this earlier when I talked about our 8-sided robots. your omni wheels give you omnidirectional movement. So if we have our plaction wheels, we can move forwards and backwards, and we can turn left and right. With omni wheels, you can go forwards, backwards. You can actually slide to the left and right without turning. You can go cardinal directions, or not cardinal. I don't know the word I'm thinking of, but if you imagine a compass, you can go north, south, east, and west without turning. You can also go northwest, northeast, southeast, and southwest without turning either. You can just drift in those directions, but you can still turn left and right if you need to. And if you look on YouTube, you can actually look up Omni Wheel Robots, and you're going to find what I'm talking about. But it gives you so much more control in the confined space of the field, but you lose out on traction. So with your rubber treads, you got a lot of traction. Your plaction, you've got a lot of traction. Pneumatic, you've got traction. With these Omni wheels, you're not getting as much traction because of how they work. The way they work is there's little rollers that spin as your wheel is spinning. And those rollers have to be free and loose because they just spin around a bolt so that you can actually drift in the directions you're trying to go. So if that's all that's contacting the ground are those rollers, and someone has plaction wheels, they're going to win 9 times out of 10 in a pushing battle. And this is why some teams have actually worked out a system they like to call butterfly drive. And butterfly drive gives you the option of omni wheels or plaction wheels. And this gets into pneumatics and gearboxes, so I'm not going to talk about it too much. But it's something that if your team uses omni wheels a lot and you really like them, but you're sick of getting pushed around, I would look into the butterfly drive. And that gives you a way to actually control your wheels, so you can change out in mid-match from plaction to omni wheels. The other one is called octomechanism drives. Same idea, just a different drive style. And I think that leads us into drive styles. So let's talk about drive styles for a sec. We have 3 main styles. We have our omni style, and that's what I was just kind of talking about. So all 4 wheels, all your omni wheels, so you can only do 4 omni wheels. There's 1 in each corner or wherever you have them placed. Each one needs its own motor. Now, if you have 2 motors going into a gearbox and you have 4 gearboxes, great. Obviously, you're limited to 6 sims, so most teams don't go that route. They'll use 1 motor on each of those wheels. And you have to do that because your left side wheels sometimes have to spin opposite each other to achieve the type of movement you're doing. It's really weird. Like I said, you're going to have to find a video of an omni wheel robot. You can actually see the wheels moving and see what I'm talking about. That's omni style. Arcade drive. This is more into the programming side of things, but arcade drive is if you have a robot and let's say you're using your plaction wheels, you have your left and your right. If you've ever played a video game, arcade, when you drive a car in, let's say, Mario Kart as a baseline, a lot of people know what I mean when I say that. You have your joystick. Well, your left joystick, or if you're going on 64, the joystick, controls your left, right, and not really your forwards and backwards, but it controls your left and right. Well, arcade drive means you're using 1 joystick to control all the wheels. Whereas my preference is what's called West Coast drive or tank drive. And that means your left side and your right side operate independently of each other. So 1 joystick controls your left wheel, 1 joystick controls your right wheel. Meaning you can control opposite directions. So if you go straight forwards with your left joystick and straight back with your right joystick, your robot's actually going to spin in place. So 0-degree turning. It also gives you a little more control because if I don't pull all the way back with my right, but I go all the way forward in my left, I can control the arc I'm turning on. Whereas with arcade drive, you can't really control your arc very well without a lot of practice. Obviously, all driving takes practice, but tank drive is what I recommend for most teams. Unless you're running out of control space, then use arcade drive because now you have a second joystick that's free to use for some other mechanism. Again, it's all up to you guys. Whatever preference you guys have, I recommend doing that over what I'm suggesting. Because you guys are going to know what you like better as a team. Alright. And I know there's a lot of stuff, so if you guys have questions, like I said, email me, let me know. I'll include my email at the end of the video, or my team's email at the end of the video. Email me, or if you are on the team, just let me know through Wigio and I'll answer your question. All right, electronics. The main electronics we're going to talk about are our motor controllers, our sensors, the Robo Rio, the PDP, also known as your power distribution panel, your PCM, your pneumatic control module, your radio, your signal light, your breaker switch, and your battery. And your breaker switch and battery, that's actually going to be one side. Originally I thought I wanted to go two, but I ended up on one because there's not a whole lot to talk about here till we get further into wiring later on. Alright, so your electronics. The main thing I want to talk about here is not necessarily how all these things work, because a lot of that gets into a difference between digital and analog and converting signals in and out, and I don't want to overwhelm you guys with information, but I want you to understand what they do. Not how they do it, but what they do. So your motor controllers, as the title states, it controls your motor, and I have an arrow pointing to the old Talon style Talon SR motor controller. Your motor controller tells the motor what way to spin, whether it's counterclockwise or clockwise, and how fast to do it. There's three main brands that you'll see with motor controllers. You've got Talon, you have Jaguar, and you have Victor. Jaguar is probably the least common of the three, and between Victors and Talons, it's kind of gotten to a tie recently. It used to be Talon that was kind of ahead of the game for a while, and then both now actually look incredibly similar and accomplish pretty much the same things. So it's all your preference which one you go with. There's some motor controllers that will come with pre-wired CAN and sensor hookups. If you want to go that route, be my guest. If you want to buy some that come with your encoders already included, cool. If not, that's what my team did. We decided to not go that route because we didn't need sensors this year. So we just bought regular ones. There's going to be pricing differences, so shop around. Like I said earlier, Cross the Road Electronics. That's who we bought all of ours from. They're great guys. They worked with us, and I know that I can trust the electronics. Plus, for us, they were literally across the road. They were right down the street. If that's not the route you want to go, no problem. You can find them on AndyMark, and Vex sells those as well. Alright, so each brand of these motor controllers kind of has its own perks, so it's pros and cons. Without getting too much into detail, if you start looking on Chief Delphi, you're going to see different people's recommendations, and you can actually get really deep into this stuff and look at, well, this one communicates at this speed, this one communicates at this speed, this one has a braking feature, this one has a coasting feature. It's really, there's a lot to look into, and if you want to, you can, but if you don't want to, you don't have to. It's not something that you need to know to understand how a robot functions, so I'm not going to talk about it. Alright, so the main thing it does is it takes a signal from the Robo Rio, and it tells the motor, where am I going, to which direction, and what speed. Alright, next let's talk about our sensors. So a little while ago I mentioned the word encoder, and you were probably like, what the heck's an encoder? Your encoder is a type of sensor that tells us how many rotations or how many degrees has the motor traveled. It just measures, how far it's spinning one way or the other. Some of them can actually measure speed because it'll measure, okay, how much time in between these two distances. If you want that information for your autonomous mode, great, get an encoder. If you don't want to, you don't have to. The sensors give you a way of reading data from your robot, and you can take that data into your robot and do something with it. There's 8 billion types of sensors, though. I mean, even if I went as simple as the Lego robot sensors, which is what I learned on first. You've got ultrasonic, sound, color/light sensor. You have your touch sensor, there's infrared sensors, and there's some other ones too that are third party. But even if we just stick with those main ones, I think I mentioned 7 or 8 different sensors that there are, and they all do different things. So your ultrasonic, you're going to be measuring distances using echolocation. Your light/color sensor, it tells you, okay, what am I looking at? If it's this color, then maybe I want to do something. So if I see a green color or a silver color, then maybe I want to do such and such. Your sound sensor, FRC, I never recommend using something reliant on sound. It's loud, it's crazy, you can't control the noises that are being made, so don't rely on a sound sensor. It's just not going to end well, I can tell you that much. Touch sensor, let's say you run into a wall in autonomous and you know what happens a lot. Maybe you have a touch sensor that stops you from running into a wall. It says, I hit the wall with my touch sensor, okay, I'm going to back up. Maybe an ultrasonic would be better so you don't actually have to contact the wall. But again, that's all up to you guys to figure out what it is you want to do. The main thing you need to understand is there's digital sensors and analog sensors. Analog means it actually has some sort of moving part. Digital means it doesn't have a moving part. It's the difference between a regular hard disk drive versus a solid state disk drive. Difference between an old style rotary phone, so the kind that had an actual dial you had to spin, versus what type of phone you have it now where it's just push buttons. So it's a difference of analog versus digital parts. Next, let's talk about the Robo Rio. The Robo Rio is the brain of the operation. It is the main thing on your robot that controls everything. This is what holds your code. This is what tells your radio to talk to you. It's what tells the PDP, your power distribution panel, where am I sending power and what am I doing. This controls everything, and it's so super duper important. You want to be super careful. You don't want this thing to get damaged. You don't want to get little specks and flecks of metal to get trapped inside of the pins that are on this thing. One thing that was recommended to us at competition was to actually tape over unused ports. I recommend that. It's definitely a good habit to get into to protect your electronics. So I'm going to work from the top down on this, and I'll specify where I'm looking at on this picture as I'm talking. So, starting at the top and kind of to the left, you're going to see something called CAN. CAN is what talks to your sensors, and if you don't use CAN, you still got to have some CAN wires attached in there or you won't pass inspection. But if you do use CAN, you're going to have to look into how each sensor works and how it relates. But that's where your sensors are going to hook up. Next to that, you're going to see your input. Your Robo Rio itself doesn't have its own power source, meaning it still gets power from the battery. And it actually comes straight from the PDP. It's weird. Your Robo Rio actually goes from the PDP and back and forth and actually hooks up to your motor controllers that go back to the PDP. And I'll talk about that in wiring, so don't worry about it too much. But your Robo Rio actually gets input from the battery through the PDP in that input spot. Next to that, you're going to see an old style USB hookup. This is not for your USB webcams or other devices you have. This is simply just for talking to your computer, for downloading code, maybe doing some updates, installing the JDKs on your Robo Rio. That's all that's for. Don't use it for anything else because you're going to get super slow transmission speed out of there. Next to that, you've got actual 2 USB ports. This is where you're going to put a USB webcam. It can also read a flash drive, but there's no reason you would have a flash drive on your robot at comp, so this is mostly just for your webcams. Webcams are great. I recommend one for your team. There's some very basic camera code out there that lets you see what the webcam sees on your smart dashboard in your driver's station. I'll talk about that. But it gives you a good eye. If you can't see what's going on in the field, you can actually see what the webcam sees live in the middle of the game. Next to that, we have an Ethernet port. This port is what hooks up to the radio on your robot, and I'll talk about the radio pretty shortly here. But this is super important. You have to have a Cat 5e, or if you have Cat 6, I don't know why you would spend extra money on it, because you don't need that high of communication speed, because you're not going to actually achieve that speed. So Cat 5, Cat 5e cable hooks up between here and your radio. Alright, we're going to skip the SPI ports, and we're going to go down the right side where it says PWM. This is for all of your motor controllers, your servos, all of that stuff gets hooked up into here. You're going to have a black, a white, and a red cord, and you're not going to know what goes where. When we get to wiring, I'll kind of specify what order they go in, and I'll give you guys a way to kind of memorize that. But this is what controls everything, and it's what sends the signal from the Robo Rio to your motor controller to tell the motor spin this way, other way, etc. this is super important. You want to make sure your PWM wires are secure. Last year, ours came out and it connected with another wire, and then it started to smoke and caught on fire at Southfield. Be careful, because you don't want to damage your Robo Rio, and that will be something that definitely damages it. The only other thing I really want to talk about on the Robo Rio is on the bottom left, you'll see something that says RSL, and this stands for your robot signal light, and we'll talk about that because that's what the light is. But this is where that hooks up on the Robo Rio. Honestly, if you have nothing else on your Robo Rio besides the things I talked about, it's still going to work and you're still going to have a working robot. We didn't use any of those other ports last year, just the ones I just mentioned. And that's the basics, and that's what we're talking about today, so I'm not going to go in depth any further. Alright, so I've mentioned the PDP a couple of times. This is your power distribution panel, and this is what gets power from the battery and sends it to your motors, well, not directly to your motors, but to your motor controllers, to your Robo Rio, to your radio, to your pneumatics control module. All the electronics have to go through here. The reason being you can't just hook things up straight to the battery is because your battery will kill those things. 12 volts is a lot more than it sounds like. I know people have said before, you want to feel electricity, you look at 9-volt battery. First of all, that's terrible advice. I don't recommend that to anybody. But 12 volts is significantly more than 9-volt battery. It's a lot of juice, and it will burn out all your other electronics if you mess with it. So you have to go through this board because this has all of our fuses in it that keep things from dying, and it has resistors, so you're not sending way too much voltage and current down the line. Your PDP on top has slots for fuses, specifically for your motors, not for anything else. Those are already built in, but fuses for your motors that come in the 30 amp or 40 amp. It depends on what size your motor is. If you're using the big slots, then that's kind of on the right side of the picture. Those are your 40 amp channels. The smaller ones are your 30 amp channels. Like I said, motors don't go straight into the PDP, but the motor controllers do. And the motor controllers act as a go-between between these two. Alright, next, let's talk about the PCM. And this is your pneumatics control module. This controls the switching of solenoids that control your pneumatic pistons. It can also control an air compressor on or off. And like I said, I'm nowhere near a pneumatics expert, so I'm going to talk about this later on. I might actually defer to someone else to do the presentation, but we'll get there when we get there. Alright, radio. The radio is not like a music player. It is what we call the radio, but it's a wireless router, and you probably have these in your house. This communicates wirelessly to the driver station where you're standing and talks back and forth and sends that Wi-Fi signal across. You can't actually get to the internet using this. I mean, you could set it up when you're all said and done, but this is just a connection between your driver station and your robot. And it's a private connection, but the radio has some ports on it, so it needs power, and that's the port you see on the far left, the black one. That power hooks up to your PDP, and then you have your Ethernet cable cords, or your Ethernet ports. There's an 1824 volt PoE, and there's one that says 802.3 PoE. Honestly, this radio, from the rumors I've heard, and we used it last year, we loved it. From the rumors I heard, this exact radio may not be making a return. The idea is the same. You have incoming and outgoing ports, you have power that needs to be plugged in, and this hooks up to your Robo Rio through one of those ports. And they'll tell you ahead of time which one it needs to be. Alright, let's talk about the signal light. Your signal light has various patterns of on and off to signal to the refs and the drivers the mode of the robot, or if something has happened, if there's been an issue. It has to be visible to everyone on the field. This is required. This isn't something I suggest. You have to do this. If it stays steadily lit, it means your bot is on and running. If it's flashing, it means either it hasn't communicated with the driver station yet, so there's not a connection there, or there's some other issue going on. Make sure to learn the actual signals when you get to competition for your robot, because it'll help you understand better what's going on. And then last thing in electronics, we're going to talk about the breaker and the battery. So like I said before, FRC uses 12 volt DC batteries. The reason we need a breaker switch is this is essentially the on and off switch for your robot. It needs to be easily accessible in case of shorting or if there's a fire. And I say fire in caps because, as crazy as that sounds, it's happened to my team before, and I'm sure it'll happen to other teams down the line. In the case of a fire, they need to be able to turn off your robot and cut the juice so it doesn't get worse. And that's what that breaker's for. All they do is slam a little red button on the top of that breaker, and it shuts the whole operation down. And again, I'll talk about this more when we get into wiring later on this summer. Alright, I know I've been talking for a while. I should be about an hour in at this point. That's a lot of talking. So we're going to talk about the drive station and controls, and then the last thing will be just the recap. Drive station controls, this is a short section, just the drive station basics and controller options. So what options are there out there? What are my recommendations? What have I seen people do? Or what have I seen other people do? Alright, drive station basics. So you can control your robot from the driver's area with the driver's station. Your driver's station has to have a laptop. I don't recommend a desktop. If you use a desktop, everyone's going to hate you because it takes forever to turn on. Have a laptop. Have a good laptop. You don't want to use a bad netbook because it's slow and you're going to run into problems. You want a decent laptop with good battery life. You're going to want a power cord because you can actually plug in when you get to the driver's spot. You're going to have some controllers and maybe some other buttons that are wired to an actual board that hook up to your computer. The picture here, this one's not super fancy, but it's definitely on the fancier side of the boards I've seen because you have two joysticks and you have those buttons on the right. Or it can be simple. What my team's done every year that I've been on the team and I've coached the team is we have a laptop, we have an Xbox 360 or Xbox One controller, and that's it. And that's all you need. And maybe we have a power cord because we've been having bad luck with batteries lately. But those are the main things you need. Some type of controller input, your laptop, and that's it. And your drive station acts as the human communication tool. So we send it an action through the joystick, and it sends that to the radio and tells it what to do. One thing I recommend, make your drive station also your main coding computer, or have all your code stored on that computer. If it's not your main coding computer, store your code, back it up onto your drive station if you need to deploy things right away on the field. Alright, as far as controllers go, there are so many controllers. Anything that hooks up USB that isn't a mouse is a USB controller that you can probably use. So I don't mean your digital camera, but stick within the realm of possibility. If you have a USB joystick for a flight simulator, that works. You have a USB steering wheel, that works. You have an Xbox 360 or Xbox One controller, that works. You have an off-brand PS2 controller because you like to emulate Kingdom Hearts. Whatever it is you've got, if it hooks up USB, it will work and you can program it to control your robot. Personally, my team has had a preference towards the 360 or Xbox One controllers. They're simple, you've got two joysticks, you've got plenty of buttons to control your actions. But if you want to use arcade joysticks, like an actual old style arcade board you would see hooked up to Pac-Man or Galaga, Fully Freeze, they're a local team around here. They actually had a full style arcade board at their competition. It looked beautiful, it gave them lots of control options. If you want to go to that route, be my guest, but you don't have to. If you are running out of time, don't worry about the drive station, worry about the robot. The drive station is like the last thing you worry about when you get into testing. You can also use the actual joysticks if you want co-drivers. Another team that I've gotten to know better over time is a local team from Grosse Pointe. They actually have co-drivers, and they sit there and one has one joystick, one has the other. So one's the driver, the other one shoots and controls the pneumatics. And it's a good system to have if you have two drivers that are very well in sync. There's so many controller options though. You really got to look into it, decide what works best for what you're trying to accomplish that year. Every year it's like a brand new team, brand new robot starting from scratch. It just takes some getting used to figure out what it is you guys prefer. Alright, so we're going to put everything I've talked about together, and I'm going to give you just kind of a general statement of what each of these parts is about. So frame. It's the body of your robot, and it's the physical aspect of your robot. Your drivetrain and your subsystems, and what moves the robot and allows for arms, shooters, etc. Your electronics, it's what powers the robot and controls the various subsystems in your drivetrain. The drive station and controls. That's the human part, so it's what takes the human interaction and converts it into wireless communication and sends those actions to your Robo Rio, or your radio, to the Robo Rio. And all these things go into building a robot, and this doesn't even get into coding, wiring, pneumatics. So it's a lot of information that you need to understand, but this is like the ground level of robots. So if you feel like you had any questions or you're not sure what's going on, again, I'll include my email at the end of this. Just let me know. I'm more than happy to answer your questions. Like I said, if this is my Team 453 listening in, just hit me up on Wigio. Most of you guys have my phone number, so call me, text me, whatever. But this is the ground level. This is the stuff that I talk about all the time, and people need to understand. And coaches, if there's other coaches listening in, feel free to show this to your kids. This is a good ground level introduction for new students you have coming in. If there's any corrections you guys feel like something I glanced over that you wanted to know more, or some type of correction I need to make, again, let me know those too. I'll include that stuff. Thank you guys for listening in. I know it's been long, so have a good rest of the summer. I'll include some more of these videos this summer as time goes on. Thanks.